we're going to talk about three trig ratios today: sine, cosine, and tangent. Okay? And so the acronym that's used to distinguish these or to help remember is SO, CATOA. Okay? And so if you see how these are abbreviated, the S is sine, the C is cosine, the T is tangent. The O's are the opposite leg, the A's are the adjacent leg, and the H is the hypotenuse. So all of these are talking, they can only talk about right triangles. Okay, so these trig ratios are ratios of sides of a right triangle. Okay, and we're going to start with the tangent ratio, which is the TOA part. So this part right here. Okay, and so when you see tangent, the tangent, or abbreviated tan, just the first three letters, tan is equal to the O, which is opposite, over the A, which is adjacent. So it's the opposite leg and the adjacent leg. So if we start off with this angle A here, the tangent of A is the ratio of the side opposite A, which is side BC, to the side or the leg adjacent to angle A, which is side AC. And so that's how you would kind of set that up from the tangent ratio. So if we gave these lengths, so let's call this a 3, 4, 5 triangle, right? The common triple. If we were looking for the tangent of A, the tangent is TOA. And I'll always refer back to this acronym. So TOA is opposite over adjacent. So opposite A would be a side of 4. The adjacent would be a side of 3. So the tangent of angle A is 4/3. And now if we had changed the perspective and you wanted to identify what's the tangent of B with respect to B, the opposite is 3 and the adjacent leg is 4. So the tangent of B would be 3/4. And so you're going to use these ratios here to identify your specific values. Okay, so the tangent, all of these trig ratios, sine, cosine, tangent, these are all ratios of different sides of a right triangle within a single triangle. So there's a couple things that you're going to be asked to do with this besides just identify again which are the adjacent and opposite sides here. So one is you need to be able to calculate trig ratios. So if we take the calculator, and I'm going to show you on Desmos here. Okay, so if you want to find what is the tangent of theta, theta is just another way to designate an angle. Okay, and so if we want to find the tangent of theta when theta is 35, it's really asking us what's the tangent of 35 degrees. And so what we can do is on our Desmos calculator, just type in tangent or select it from this drop down here under functions. Notice, or it's kind of up. Notice here it's up higher on this calculator, but I'm just going to type in the word tangent. And then type the angle, which is 35. Now, here's the thing. There's two different ways that angles are going to be entered, either radians or degrees. And we're most familiar with degrees. However, lots of calculations, and including the calculations in MyOpenMath, are only done in radians. And we've talked about the conversion for degrees and radians, but the calculator for Desmos, if you just go into this little tool kit or this tool icon, change the settings and scroll down to the bottom, you can change it into degrees. So make sure that whatever calculator you're using is set to degrees before you enter your answer. And so here we see 0.7002. If you round it to at least 4 decimals, and that would be your answer. Okay, so really quickly answer the question right below that. And can you find what would be the tangent of theta when theta is 126 degrees? And again, just whatever calculator you are going to use, make sure you can do the trig ratios with it. Because, again, sometimes getting it into the right mode, so making sure it's in degree mode, is something that you need to pay careful attention to. So here I have the tangent of 126 degrees. I already know that I'm in degree mode. So I have my answer, negative 1.3764 if I round it to 4 decimals. All right, so part of what you're going to be asked to do is that, just to be able to calculate on whatever calculator you're using. The other thing that you're going to be asked to do is to use these trig ratios in calculations. And so all of our slides that we're going to talk about today are going to be basically these same types of problems. I'm going to show you how to use your calculator first. Then we're going to do, or first I'm going to define it, show you how to use the calculator, and then we'll set up some problems, solve some problems, and then we'll solve some word problems or story problems involving them. So if we look at this first example right here, and they ask you, find the value of x in this right triangle. Again, SOHCAHTOA, sine, cosine, and tangent are used for right triangles. So if you look at this triangle right here, it doesn't specifically tell you you have to use the tangent. So what you would need to do is find out how do these elements relate to each other. Easiest way to do that is find the angle that's involved. So here I'm circling that. And then look to see how do these other two pieces of information relate to this angle. Well, we have the leg opposite, that's O, and we have the leg adjacent, that's A. So when you look at these trig ratios, so SOHCAHTOA, which pattern is OA fitting? TOA, which stands for tangent, and so that's the ratio you're going to use. So you'll set up the ratio tangent of 49 degrees is equal to the opposite leg 9 over the adjacent leg x, and that is your equation. The next thing you do to solve this equation, we need to first get x in the numerator, and then we need to isolate it completely. Now, if we enter this directly on Desmos, and so if we just type this whole equation in, so tan of 49 equals 9 over x. Notice it gives us a line here. We can actually, like we do have a solution. This, where it crosses the x-axis here is your answer, but it doesn't display the answer when x is in the denominator. So what we want to do is we want to make sure x gets moved to the numerator. So if we cross multiply or multiply both sides of this equation right here by x, okay, so I'll come here. If I multiply both sides of this equation by x, my x's cancel, and I get x times the tangent of 49 degrees equals 9. Well, if I enter that in my calculator, so x times the tan of 49 equals 9. Notice now I do have that dot where it crosses the x-axis, and so I can see that my answer is 8.2 or 7.824. Now, if we needed to do calculations with this number, anytime you do further calculations, you have to use the exact number, not an approximation. So the 7.824 is not really as precise as what we can get. And so if you do need to, so this is fine where this answer is, right? It asks you for the nearest tenth. We've already gone past that, so we're good with our answer here. But if you ever needed to use this as a further calculation in the problem, what you would want to do is completely isolate your x. So to take this equation and solve completely for x, what we would do is then divide by the tan of 49. And so that would cancel, and we get x is equal to 9 over the tangent of 49. And so if we entered that in our calculator here, so if we just said 9 divided by the tangent of 49, now notice we have our more precise number. So now this is an exact number. We can use it in other calculations. So it all depends how precise you need to be to identify like how you need to make these calculations. Okay. All right. So what I want you to do is see if you can, oh, actually, let me go in one more thing. If you were entering this on MyOpenMath directly, okay, you can enter a calculation on MyOpenMath. Okay, so if you were entering this just in the answer field, the only thing that you need to account for is that MyOpenMath only reads angles as radians. So if you were entering this in MyOpenMath, you would say 9 divided by tangent of, and when you look at 49 degrees, you would have to convert from degrees into radians. Does anybody remember what that conversion is? Yes. Yeah, so 180 degrees is equivalent to pi radians. And so if you put pi over 180 right here, this would also give you a correct response in MyOpenMath. Okay, now, in my opinion, it's easier just to work in degrees, use a separate calculator and enter your answers. But if you do want to enter directly and not use a calculator, you just need to make sure that you convert everything into radians when you enter it on MyOpenMath. All right, so now go ahead and try this problem right below. And see if you can find what is x in that diagram. So once again, if you look at the diagram, you don't know which trig ratio to use because eventually you have all three of them to choose from. So you take the reference angle, 54 degrees. With respect to that, we have the leg opposite and we have the leg adjacent. OA corresponds to TOA, which is tangent. And so we can set our equation, the tangent of 54 degrees is equal to opposite x over adjacent 19. Now, notice when the x is in the numerator of an equation, we get our answer with the point on it. So if we just type this equation, tan of 54 is equal to x over 19, what we can do is we can find our equation. When we scroll out or over, we get 26.151. We see where that is located. As long as you round it to at least the nearest tenth, you're good. And so that would be an acceptable answer. There's no need to go any further when the variable's in the numerator. Now, if you needed more decimal points, so if it asked you to round it to at least 4 decimal places, what you would need to do is to solve for x here. You would need to multiply both sides by 19. And so if we took this equation right here, got rid of the 19 and just multiplied in front 19 times, now we get the same answer, but we have more decimals. This is the exact answer. It's more precise because we have more of the decimal places. And then finally, if you were entering this as an answer directly on MyOpenMath, you could have entered it as 19 times the tangent of 54 degrees, but instead of degrees, we would need to convert it into radians, which has the conversion pi over 1/8. Pi radians is equivalent to 180 degrees. So that would be the other way that you could enter your answer if you wanted to put it directly in your answer field on MyOpenMath. So again, experiment with whatever makes the most sense to you, okay? And you can use any of those methods. All right, so I want you to try these last two questions for me, please. These story problems. Like I said, right now I'm breaking them down, and so you kind of have an idea that these are going to be this specific trig ratio. But the key when you guys are taking your quiz or your test is you're going to need to be able to determine which ones are sines, which ones are cosines, which ones are tangents. So make sure you're following that process of testing them before you solve. Looking at the problem, again, trig ratios, we're only going to use them, the sine, cosine, tangent ratios for right triangles. So here we see a right triangle. We have a known angle of 61 degrees. We have an unknown opposite leg. And we have a known adjacent leg. So opposite and adjacent is TOA, which is our tangent. And so what we can do is we can set up our equation. The tangent of 61 degrees is equal to our opposite, the unknown height, over our adjacent 39. And so again, all I need here is the nearest tenth. So when I do calculate this, I can just set up my whole equation. So I can say the tan of 61 degrees equals, I'm going to use x over 39. And as I do this, again, I'm going to scroll out to see where this intersects. I see 70.358, and that'll be my answer. Okay, now, if I were to solve this and need more decimals, I can multiply both sides by 39 to get h alone. If that was the case here, again, I would just take my equation out of the mix and put 39 times here. So now I have the same answer, just more decimal places revealed. And finally, if I was entering my answer directly into my open math, I could also say 39 times the tangent of 61 degrees, convert it into radians by multiplying by pi radians over 180 degrees. And so this would be the way I could enter this directly on the MyOpenMath system.
I have a quick question.
Sure.
For entering it on MyOpenMath, on like the first problem we did 9 divided by 10. Was that just an accident, or is that you need to do it divided by?
No, so it all depends where the variable is. So notice on this first one, the variable started out in the denominator. And then you're going to see that here, or actually, it's not on either of these story problems. But if the adjacent leg was your unknown, then it winds up in the denominator, and it'll be, when you rewrite it, it'll be in the denominator too. All right. So this final example, we have a right triangle, so we're using trig ratios. We have a known angle of 51 degrees. We have an opposite leg that's unknown. We have an adjacent leg that's unknown. So OA is TOA, which represents tangent. So the tangent of 51 degrees is equal to opposite H over adjacent 88. Once again, since our variable is in the numerator, we can just type this directly in Desmos. So tan of 51 equals H over 88. If we scroll out to see where our answer is, turn the H into an X so you can see it on the graph. And we get our answer to be 108.671. This one, again, it just needed to the nearest tenth, so you're fine. You can round it if you wanted to. If we were solving this and needed more decimal places, we can multiply both sides by 88 to get H completely alone, which here, once again, if we just multiplied, put the 88 in front, we'd get our same answer, just more decimal places. And if we were entering this answer right here, 88 times the tan of 51 degrees, we would need to convert from degrees to radians using pi over 180. And so we could have also entered the calculation directly on MyOpenMath this way. All right. So that is sort of the process of what you're going to see here on the next couple slides as well, okay, using the different trig ratios. So let's look at the next trig ratio, sine. Okay, so again, if we were looking at our SOHCAHTOA, sine is this SO part. And so when you're looking at the ratio sine is going to be the ratio of the opposite leg to the H, the hypotenuse. And so that's the ratio you're looking at. Sine, cosine, and tangent are all designated using just the first three letters of them. So SIN, even though like students will pronounce this sin, it represents sine. And so this is sine of A is equal to, with regard to A, we have OA, opposite, and hypotenuse. Or the O, so is opposite and hypotenuse. So the sine of A is BC, the opposite leg, over the hypotenuse, which is AB. And once again, if we were designating these as a 3, 4, 5 right triangle, so leg of 3, leg of 4, hypotenuse of 5, the sine of A would be opposite 4 over hypotenuse 5. The sine of B would be adjacent to A, the opposite of B, which is 3, to the hypotenuse 5. So those would be your trig ratios for angle A or angle B, depending on your perspective. All right, so just really quickly, see if you can use your whatever calculator you're using, okay, to find what would be the sine of 35 degrees and 126 degrees? Again, sine, cosine, and tangent, you're just going to use the first three letters of the word to evaluate the trig ratio. So here we have sine of 35 degrees. Again, make sure you're in degree mode. If you miss an answer, double check and make sure that you're in the correct mode. So 0.5736 is the sine of 35 degrees. Sine of 126, we can just change that number and we get 0.8090 as your answer. All right, so try the next two. Again, here you're just finding your unknown given a right triangle. All right, so here if we are evaluating these two triangles, what we're going to see, we have a right triangle, means trig ratio. We have a known angle. With respect to this angle, we have the opposite leg and the hypotenuse of the right triangle. So that's telling us we're using the sine. So the sine of that angle, 20 degrees, is equal to the opposite 9 over the hypotenuse x. So once again, here we have our variable in the denominator, so we want to get it out of the denominator. So if we multiply both sides by x, we could leave it in this form. If you took x times the sine of 20 is equal to 9, you get an answer. You could click on it. 26.314 is our solution. We can stop there. If you need more decimal places, just solve for x here, right? And so to solve for x in this equation, we would then need to divide by the sine of 20 degrees. And so 9 divided by the sine of 20 would be our answer. Notice we get the same answer, just more decimal places. And if we wanted to enter our answer directly into the MyOpenMath system, we could have used this equation. Or the calculation 9 over sine of 20, but because 20 is in degrees, we'd need to convert out of degrees, which is pi radians per 180 degrees. And so this would be the calculation if you are leaving it in that form, okay, entering it directly as a calculation. All right, the second problem here, we have our right triangle. So either use, again, Pythagorean theorem, or because we have an angle involved, we'll use trig ratios. With respect to this angle, we have the opposite and the hypotenuse. O and H are the sine. So sine of 18 degrees is equal to opposite x over hypotenuse 14. Now, because our x is in the numerator, we can just type it directly. Sine of x equals, or sine of 18 equals x over 14. And then we click. Notice I can zoom in, but as long as I see where that intersection is, the 4.326 would be my answer. I just need to round to at least the nearest tenth, so I'm already more precise than what I need to be. If I want to, more decimals, I can isolate the x completely by multiplying both sides by 14. And so if I take this equation right here, multiply both sides by 14, I get my same answer, just more decimal places. And then finally, if I'm entering this on MyOpenMath, 14 times the sine of 18 as degrees, so I convert pi over 180 into radians. And so that would be the entry that if I wanted to answer directly. All right. So the final two questions from this slide, see if you can answer these, please. These are the story problems that are setting up and using sine ratios. Of these, and they're not just all the same. becomes a little bit more challenging. So make sure that you are thinking about the process. So here we see our right triangle. Now, this has this phrase in it called angle of depression. Okay, there's two perspectives that you can use for some of these story problems. Angle of depression means if you're looking straight ahead and your eyes move down, that's an angle of depression. So again, assuming that you're looking out this way and your eyes move down, this angle of 26 degrees is the angle of depression. Now, if you happen to be using this triangle down here, so if you were using this triangle as your reference, and you were looking out this way, and you were from the base of that triangle looking up, now instead of your eyes depressing or going down, they're elevating. So this is called an angle of elevation. So if your eyes move up, it's an angle of elevation. If your eyes move down, it's an angle of depression. And they'll both refer to the same thing. So if you had the perspective of being at the base of this hill looking up at the skier, this would also be 26 degrees for that angle of elevation. Now think about what these are, right? These are alternate interior angles of parallel lines. That's kind of how or why those would be the same. But just depending on the wording that's given, make sure you're using the correct spot for your angle. I think most of them, they should be labeled, so there shouldn't be a huge way or reason to mix them up. But if you take this right triangle, we have an angle, we have a known opposite leg, and we have an unknown hypotenuse. So opposite and hypotenuse is O from so, which tells you you're using sine. So the sine of 26 degrees is equal to opposite 6,000 over hypotenuse, which is x. In order to solve this, we do need to multiply both sides by x to get it out of the denominator. When we do that, we can do our calculation right here. So if we want to say x times the sine of 26 is equal to 6,000, okay, we can zoom out and find that. Now, notice in order to zoom out and find this, we have to zoom out quite a bit. Okay? So this is maybe not the easiest way to find this answer, although you can. 13,687.032. If you go ahead and solve for x, divide both sides by sine of 26. These cancel, and so you get your answer to be 6,000 divided by the sine of 26. Notice it's just an easier way to find the answer here rather than scrolling in and out, zooming in and out to find where that's located on the graph. Okay? So it's up to you, whatever your preference is. Okay, and then this final question here. Again, when you look at the right triangle that's involved, you have an angle of 39 degrees. You have an opposite leg and a hypotenuse again. Opposite and hypotenuse is O for so. That means we're looking at the sine, once again, of 39 degrees is equal to opposite 6 over hypotenuse x. Oops, going back here. Again, if you wanted to enter this on my open math, it would be 6,000 divided by the sine of 26 degrees times pi over 180 would be the conversion for that. Okay, back to the current problem. We've set up our ratio. X is in the denominator, so we want to get it out of the denominator. Multiply both sides by x. And so our answer is either x times sine of 39 equals 6, or I'm going to go ahead and just divide both sides by sine of 39. And that is my answer, 6 divided by sine of 39. I see the answer to be 9.534. You can round it to whatever they ask you in this case. It's only one decimal place, or to the nearest tenth. And if I was entering my answer on my open math, 6 divided by sine of 39, convert pi over 180, converts degrees to radians. And so that would be my other way that I can enter the answer directly. All right, so that's sine and tangent. The last remaining trig ratio that we're going to look at is cosine. And once again, if you look at SOHCAHTOA, cosine is adjacent over hypotenuse, A and H. So your cosine ratio is going to equal adjacent over hypotenuse. And if we looked at with respect to angle A, cosine is adjacent, which is the length AC or the leg AC over hypotenuse, which is AB. And so once again, if we looked at this as a 3, 4, 5 common triple, cosine of A and cosine of B. Cosine of A is adjacent 3 over hypotenuse 5, and cosine of B would be adjacent 4 over hypotenuse 5. And so that's how you would set them up if you're given that full triangle. All right, so once again, see if you can answer these two questions here. So here we're just evaluating the cosine of 35 degrees. Just type it directly in. Make sure you're in the right form. 0.8192 is my solution. Test it for 126. We can simply change 35 to 126. We get 0.5878. So once again, straightforward, just finding the calculated values. All right, next, see if you can answer the straightforward applications on a right triangle based on the information provided. Hopefully this is not anything that's really like overly challenging. It's the idea of determining which of these three you use, and that's going to be the part that is the challenging part to this. And because you have these three different forms that you have to test. Okay, so when you're setting this up, you have a right triangle with an angle of 38 degrees. With respect to this angle, you have an adjacent leg and you have the hypotenuse. Adjacent to hypotenuse is cosine. So the cosine of 38 degrees is equal to adjacent over hypotenuse. Our variable's in the denominator, so we want to get it out of the denominator. I'm going to multiply both sides by x. Okay, and so once again, so I don't have to go in and find it on the graph. I'm going to go ahead and solve for x. And when I do, I get 15 over cosine of 38. So if I type 15 over cosine 38, I get my answer to be 19.035. If you round it to the nearest tenth, you're good, but that's a little more precise. And if I was entering this directly online or on my open math, again, I would have had 15 divided by the cosine of, and instead of degrees, 38 times pi over 180 would be my conversion. And so this would be an acceptable form as well. The next one, with regard to the diagram, I have a given angle, the adjacent leg, and the hypotenuse. That's from the SOHCAHTOA. So this is cosine of that angle, 47 degrees, is equal to adjacent over hypotenuse. Multiply both sides by 12 to get my x alone, and so there is my calculation. 12 times the cosine 47, giving me an answer of 8.184. Or if I'm using a calculation directly, I would take 12 times the cosine of 47, and instead of degrees, multiply that by pi over 180. That all needs to be done inside the trig ratio, and you can enter your answer as a calculation instead. Right, so try these last two story problems. So I've tried to label all of your diagrams for you. So I mean, like, you can read through the story problems themselves, but I've tried to make it as simple as possible so that you can just look at the diagram. You have an angle, you have an adjacent leg and hypotenuse. Adjacent and hypotenuse is ka, which is cosine. So the cosine of that angle, 36 degrees, is equal to adjacent 58 over hypotenuse x. And we need to get x out of our denominator. And I'm going to isolate it and divide both sides by this cosine of 36. And that allows me to enter my calculation directly here. So 58 divided by cosine of 36. And I get my answer to be 71.692 for my answer. And once again, you can enter your answer directly as a calculation. So 58 over the cosine of 36, but instead of degrees, pi over 180 to convert into radians. So that would be an acceptable calculation. Okay, and for this last problem, I have a known angle, an adjacent leg, and a hypotenuse. So that represents ka, SOHCAHTOA. So the cosine of that 17 degrees is equal to my adjacent x over my hypotenuse 19. And once again, I could leave it as the calculation, or as the equation. Okay, I'm going to go ahead and multiply both sides by 19 to get x completely alone. So I have 19 times the cosine of 17. Again, this is a 9 here. Okay, and when I calculate that, I get my answer to be 18.170. And if I was entering my answer as a full calculation, it would be 19 times the cosine of 17 degrees. Again, convert that pi over 180 into radians to enter my answer directly.